The story of Operation Crossbow begins with a simple truth. Britain was never meant to survive the winter of 19. According to German plans, London was supposed to be buried under thousands of high-speed rockets fired from underground launch sites, stretching across northern France and the Low Countries. These weapons were not prototypes or fantasies. They were real, fully engineered, and already entering production. The V-1 flying bomb had already struck British cities by the thousands. But the V-2 rocket represented a new kind of threat. It could not be intercepted. It could not be tracked. It arrived without warning at more than 3,000 miles per hour, exploding before human senses registered the sound. British and American intelligence understood that if these rockets were launched in mass numbers, the psychological, political, and industrial consequences would be severe. The entire structure of Britain's war effort depended on concentrated urban labor, functioning ports, and stable government. A sustained campaign of heavy rockets aimed at London risked triggering evacuations, industrial shutdowns, supply paralysis, and mass panic. It was not simply a matter of casualties. It was a question of national continuity. Every intelligence estimate across 1943 and 1944 concluded the same thing. The V-2 program had to be destroyed before it reached operational scale. What made the threat urgent was the speed of German progress. At Peenemünde on the Baltic coast, teams of engineers working under Werner von Braun and Walter Dornberger had moved from small-scale test stands to full underground production networks. The rocket was powered by a liquid oxygen alcohol engine and guided by a gyroscopic control system that gave it unprecedented accuracy for the era. Its range meant that sites far from Allied bombers could still threaten the heart of London. The guidance section, fuel tanks, and warheads were being produced in multiple dispersed facilities to prevent single-target destruction. Germany, despite losing the conventional air war, still had enough scientific depth to push the project forward at a pace that alarmed Allied analysts. In Washington and London, debates erupted over how to respond. Traditional strategic bombing had inflicted serious damage on German industry, but the V-2 sites were deeply buried, heavily reinforced, and sometimes hidden in forests and quarries. Even when reconnaissance aircraft identified suspicious structures, the exact purpose and internal layout remained unclear. A normal bomber group could not guarantee the destruction of an underground launch chamber hardened with steel and concrete. Operation Crossbow emerged from this dilemma. It was a combined intelligence, photographic analysis, deception, and precision bombing campaign designed to locate, track, degrade, and ultimately neutralize the rocket threat before the system reached full operational deployment. The complexity of the campaign was extraordinary. The launch sites came in different types: ski sites designed for V-1s, large blockhouse complexes for V-2s, and rapidly assembled mobile platforms that could fire a rocket and immediately relocate. The mobile sites were the most dangerous. Fixed sites were vulnerable to heavy bombardment, but mobile launch platforms could hide in wooded areas, fire within minutes, and disappear before reconnaissance aircraft arrived. The only reliable countermeasure was to target the entire infrastructure surrounding the rockets: fuel production facilities, guidance, instrument factories, transport networks, and the research centers that linked all of it together. This was the heart of Operation Crossbow's logic. If the Allies could not destroy the rockets at the launch point, they would destroy the supporting system that made large-scale firing possible. The campaign began with intensive aerial reconnaissance. British Mosquito aircraft, flying at high altitude and high speed, photographed suspected test ranges and construction sites along the French coast. Analysts at Medmenham, Britain's interpretation center, examined each image frame by frame. They learned to identify subtle patterns: elongated concrete foundations, rail sidings connected to forest clearings, ventilation shafts emerging from hillsides, and unusual shadows cast by partially buried structures. Every detail mattered. A slight change in ground texture could indicate recent excavation. A line of disturbed soil could mark cable trenches. By 1944, the interpreters could identify a rocket site even before its major components were complete. Once identified, the targets were handed to the bomber commands. But bombing them was far from straightforward. Many sites were shielded by heavy anti-aircraft guns and designed to absorb enormous explosive force. The RAF's heavy bombers attacked at night with large blockbusters, aiming to bury or crack the launch chambers. American heavy bombers attacked during the day, relying on precision to strike critical construction points. Losses were significant. The Germans knew the importance of these sites and defended them accordingly. Yet Crossbow missions continued, because the stakes demanded it. One of the most significant operations was the bombing of Peenemünde in August 1943. This raid temporarily delayed the rocket program by disrupting testing and killing key personnel. But the delay was not enough. By early 1944, V-2 production had been shifted underground to the vast Middlework complex in the Harz Mountains, where forced laborers assembled rockets under brutal conditions. This move made direct destruction nearly impossible. The Allies had to target transportation networks and storage depots instead. Rail lines, bridges, marshalling yards, and fuel trains became priority targets. Every disruption slowed production, delayed deployment, and reduced launch capacity. Even with these efforts, V-2 rockets eventually began to strike London in September 1944. They were terrifying weapons, and the damage they caused was severe. But the number of rockets that reached operational use was dramatically smaller than what Germany had planned. The original objective was to fire thousands each month in a continuous bombardment. Instead, production bottlenecks, transport losses, damaged facilities, and constant Allied pressure kept launch rates low. Britain suffered, but it did not collapse. That strategic outcome was the direct result of Operation Crossbow's relentless campaign. The threat that Operation Crossbow sought to eliminate did not begin with the launch ramps in France, nor with the concrete bunkers of the Potomac. It began years earlier inside Germany's secret research centers, where engineers attempted to solve a question no army had ever answered: how to strike an enemy capital without aircraft, without pilots, and without warning. The V-1 flying bomb and the V-2 ballistic missile were not built as weapons of battlefield utility. They were conceived as instruments of terror, designed to force Britain into political collapse. Every technical breakthrough the Reich achieved pushed London closer to the possibility of mass, indiscriminate destruction. The V-1, the first operational weapon in this arsenal, was simple in concept but deadly in effect. Upholstered engine, welded atop a narrow fuselage, could carry a high-explosive warhead more than 150 miles at over 300 miles per hour. It did not need accuracy. Its purpose was psychological. Hundreds launched in quick succession could turn London's residential districts into fire zones. British intelligence estimated that if Germany reached full production, thousands of these weapons could be fired monthly. But the V-1, fast as it was, remained interceptable by fighters and anti-aircraft guns. It was the second weapon, the V-2, that presented a threat without precedent. The V-2 rose from its launch platform at more than 3,000 miles per hour, arching into the stratosphere before plunging toward its target faster than the speed of sound. No radar could track it, no fighter could reach it, no gun could stop it. A V-2 strike offered no siren, no warning, no defense. The missile simply appeared as a flash, a pressure wave, and a column of dust. It was the world's first true ballistic missile. Worse still, German planners envisioned mass production. If enough launch sites survived, if fuel stocks held, and if the Reich maintained manufacturing in the Ruhr and Middle, London could face thousands of high-velocity impacts in a matter of weeks. This possibility shaped every decision behind Operation Crossbow. The Allied goal was not merely to reduce damage, but to prevent a scenario in which the British capital endured sustained bombardment beyond anything seen in the Blitz. As early as late 1943, aerial reconnaissance identified unusual construction patterns along the French coastline: heavy bunkers, long concrete ramps, fuel storage caverns, and rail spurs leading into coastal valleys. Each image pointed to the same conclusion: Germany was building a missile belt aimed directly at the heart of the United Kingdom. Crossbow expanded accordingly. Yet even this level of bombardment could not eliminate the threat entirely. Many of the launch sites were built underground, and German crews could assemble and fire missiles from concealed positions. Moreover, intelligence suggested the existence of mobile launchers capable of shifting positions within hours. Every V-2 that arced into the atmosphere reminded London that Crossbow was a race, not merely against German industry, but against time itself. And time remained uncertain. If German production reached projected numbers, and if launch crews survived long enough to coordinate mass firings, London would face the nightmare scenario planners feared: sustained, unpredictable impacts across the city. The Blitz had been visible, audible, and largely intercepted. A Vuipan barrage would be silent until the moment of detonation. The psychological effect alone threatened to destabilize civil order. By late 1943, the intelligence picture around the Vuipan complex shifted from speculation to certainty. Through a combination of aerial reconnaissance, decrypted Enigma traffic, and resistance reports, the Allies understood that Peenemünde was only the beginning. The German program had fragmented: design and testing on the Baltic coast, mass production in underground factories, and operational launch units hidden across northern France and the Low Countries. Each component required a different type of assault. For crossbow planners, the challenge was no longer simply identifying targets, it was prioritizing them before operational deployment. Scaled beyond control, the launch sites discovered in the Pas-de-Calais region revealed a new level of German engineering ambition. These installations, codenamed Wasserwerk and Stallenbau, were reinforced with concrete arches up to 10 feet thick, protected by flak batteries, camouflaged railway spurs, and subterranean storage chambers capable of holding dozens of V-1 missiles. Unlike Peenemünde, which relied on open-air facilities, the Calais complex aimed to withstand continuous bombardment. The Luftwaffe believed that even if the Allies located the launch ramps, destroying them fast enough would be impossible. In response, the Crossbow target list grew from a handful of research centers to more than 1,000 strategic points: launch ramps, fuel depots, rail choke points, assembly halls, guidance workshops, and tunnel complexes. Operational pressure intensified in June 19. When the first V-1 missiles were launched toward London, the initial wave numbered only a few dozen, but the strategic implications were unmistakable. The flying bomb moved at over 350 miles per hour, flew too low for standard radar coverage, and could not be intercepted by conventional anti-aircraft tactics. Fighter squadrons modified their approach, learning to tip the V-1's wings mid-flight to destabilize them, while anti-aircraft batteries repositioned south of London to intercept them over open fields. Yet even with these adaptations, a significant number reached urban districts, causing casualties, fires, and a wave of psychological shock. Crossbow was no longer preventive. It had become a race against an expanding bombardment. Compounding the crisis was the emergence of the V-2 rocket, faster, higher, and completely unstoppable once launched. Signals intelligence indicated that Germany planned to deploy hundreds of V-2 launch units across Belgium and Holland. Unlike the fixed V-1 ramps, these were mobile, concealed in forests, able to fire and relocate within minutes. Their logistical tail, liquid oxygen production, alcohol fuel shipments, gyroscope calibration equipment, became primary Crossbow targets. Destroying them required surgical strikes. American 8th Air Force and British Bomber Command adopted new penetration tactics, flying at lower altitudes despite heavy flak exposure to ensure precision hits. Many of these raids suffered severe losses, but the alternative was allowing the bombardment to scale unchecked. One of the most critical components of Crossbow's evolution was the recognition that German launch capacity depended heavily on railway resiliency. The Wehrmacht attempted to maintain a constant flow of components, fuselages manufactured in North, guidance systems assembled near Friedrichshafen, fuel processed in Plitz, and mobile launch teams deployed throughout Western Europe. Crossbow analysts concluded that severing the rail arteries feeding these sites could delay or even cripple launch schedules. This led to the Transportation Plan, a campaign of systematic strikes on marshalling yards, tunnels, bridges, and junctions. Though controversial due to expected civilian casualties, the campaign substantially delayed V-2 deployments, reducing the volume of rockets that ultimately reached British soil. Throughout late 1944, a debate emerged between Churchill, Eisenhower, and the combined chiefs of staff. Should Crossbow remain the highest bombing priority, even above oil facilities and transportation hubs crucial to the German war machine? Churchill viewed the V-weapons as a direct threat to British civilian morale, arguing that sustained bombardment could jeopardize political stability. American commanders tended to prioritize strategic industrial targets, arguing that Germany's defeat would render the V-weapon threat irrelevant. The compromise was an alternating priority schedule, with Crossbow raids surging in response to increased launch activity. Intelligence cycles dictated tempo. Each time a new cluster of launch sites was identified, Bomber Command redirected forces accordingly. By December 19, Crossbow's pressure was beginning to fracture the German program. Many reinforced sites remained under construction. Mobile V-2 units operated at reduced efficiency due to fuel shortages, disrupted communications, and limited guidance calibration. Even so, hundreds of V-2s struck London, Antwerp, and Liege, inflicting casualties without warning. But the critical outcome, the one rarely understood outside intelligence circles, was scale suppression. Without Crossbow, the Germans intended to fire thousands of rockets into London. With it, they managed only a fraction of the planned bombardment. As the Crossbow campaign intensified in early 19, Allied intelligence continued mapping every component of Germany's long-range weapons network. Reconnaissance aircraft photographed launch platforms hidden in forests, camouflaged storage depots, and concrete bunkers built to assemble the remaining V. Each image was analyzed by specialists who tracked transport routes, fuel depots, and railway patterns to determine where the next wave of launches might originate. Despite months of bombing, German engineers were still attempting to restore firing capability along the Channel coast, hoping to send a final barrage toward London. The most dangerous of these recovery attempts occurred in the Pas-de-Calais region. Here, under increasing secrecy, German crews tried to repair damaged V-1 ramps and reposition mobile V-2 launch teams. The Allied response was immediate. Night bombers struck the area repeatedly, while fighter bombers attacked convoys moving through narrow roads. Even minor infrastructure bridges, tunnels, switching stations became targets, ensuring that any movement of rockets or fuel would be slowed or stopped. The goal was total paralysis of the launch network. Underground sites posed a greater challenge. At the Middlework complex, thousands of forced laborers continued assembling V-2 rockets within tunnels carved deep into the mountain. The Allies knew the facility existed but could not destroy it, without causing massive civilian death among the enslaved workers. Instead, Crossbow shifted to disabling the rocket's logistical chain, destroying rail lines feeding the tunnels, cutting power connections, and targeting fuel storage. By spring, the German rocket program was running on fragments, interrupted production, limited propellant, unreliable launch teams, and severe shortages of guidance components. Meanwhile, British air defense expanded its radar coverage along the eastern and southeastern approaches to London. Specialized tracking stations were calibrated to detect the supersonic signature of incoming V-2s as early as physics allowed, even though the rockets could not be intercepted. Civil defense networks prepared rapid response teams to manage debris, fires, and casualties. Analysts compared blast patterns across the city to determine whether Germany was adjusting its aim or experimenting with improved guidance. Every scrap of data fed back into the Crossbow effort. As Allied armies pushed deeper into Germany, ground units began overrunning storage sites, capturing intact V-2 components, mobile launch vehicles, and technical manuals. These discoveries confirmed what Crossbow planners had predicted. Germany had planned for thousands of rockets to fall on London, but the combined pressure of bombing, sabotage, logistical collapse, and relocation forced the program into fragmentation. What remained were scattered launch attempts, each less effective than the last. The final breakthrough, Operation Crossbow, closed with analysts reviewing the total arc of the rocket war. From the first V-1 attacks to the collapse of the V-2 network, they concluded that without continuous Allied pressure bombing, intelligence work, sabotage, and ground offensives, London would have suffered destruction on a scale unmatched in the war. The thousands of rockets planned for the British capital never materialized because the infrastructure behind them was methodically broken faster than Germany could repair it. Crossbow had succeeded in the most strategic sense. It prevented a catastrophe rather than responding to one. By early 19, Allied reconnaissance had mapped a web of V-weapon launch sites stretched across northern France and the Low Countries, ski-shaped firing ramps, bunker complexes, underground tunnels, camouflaged fuel depots, and mobile transport columns hidden in forests. Yet bombing proved far harder than identifying them. The Germans rebuilt sites in weeks, sometimes days, repairing ramps, replacing equipment, and shifting crews from one zone to another. Crossbow therefore entered its next, more aggressive phase: continuous suppression, a relentless cycle of reconnaissance, target verification, and precision strikes designed not to destroy the V-weapon project outright, but to keep it permanently off balance. The U.S. 8th Air Force and RAF Bomber Command divided responsibilities. Heavy American bombers attacked hardened structures with deep penetrating ordnance such as the 5,000-pound Disney rocket-assisted bomb and the older armor-piercing series. The RAF focused on night raids against storage depots, laboratories, and underground assembly lines. Fighter bombers, particularly the P-47 Thunderbolt and the rocket-armed Typhoon, executed daytime low-level sweeps to destroy mobile launch trailers before they could be positioned. Crossbow became not a single mission, but a grinding, daily war within the larger war. Still, the V weapons kept coming. By the summer of 1944, more than 8,000 V-1 South had been launched toward Britain. Many fell short. Many were destroyed by fighters or anti-aircraft guns, but enough penetrated the defenses to kill thousands and injure tens of thousands. Each new impact triggered public fear and political pressure. Churchill demanded deeper strikes. The War Cabinet demanded results. Intelligence analysts warned that if even a fraction of the planned V-2 inventory became operational, London could face destruction on an unprecedented scale. The Allied response intensified. Reconnaissance mosquitoes flew missions so dangerous that crews sometimes returned with engine cowlings, scorched by ground fire. Photo interpreters at RAF Medmen examined tens of thousands of prints per week, searching for shadows, tire tracks, fresh earth, and the faint geometric signatures of launch equipment. Ultra intercepts provided hints, logistics requests, fuel shipments, transportation orders. Cross-referencing these streams created a constantly shifting map of German intentions, allowing planners to strike supply lines and choke points rather than individual ramps. As the Allies pushed deeper into France after D-Day, fighter groups began sweeping over V-weapon corridors with mounting aggression. Mobile V-1 launch units, once shielded by forest cover and French terrain, now faced strafing runs multiple times per day. The P-47 Thunderbolt proved especially lethal. Its armor allowed it to absorb ground fire, and its .850 caliber guns shredded trucks, fuel drums, and launch trailers in seconds. Some pilots later described the campaign as hunting steel insects, a brutal but necessary effort to keep the ramp crews constantly rebuilding, relocating, and remeasuring firing geometry. Meanwhile, the search for the deeper threat, the V-2, became a race against time. The rocket's mobility meant that even an intact site could be abandoned in minutes. But Crossbow planners discovered something more exploitable: the logistical backbone, the choke points through which propellant, combustion equipment, and precision guidance components had to move. Bombing these turned out to be more effective than attacking the rockets themselves. Chemical plants, railway nodes, and specialized machining workshops in Germany and occupied territories suffered devastating raids. Each impact delayed the V-2 rollout by weeks or months. Yet despite these efforts, V-2 South finally began raining down on London in September 1944. Unlike the V-1, the V-2 gave no warning, no engine buzz, no time for fighters to intercept, no chance for guns to fire. They fell at supersonic speed, detonating with lethal force. And yet, the scale of the bombardment never matched German projections. Albert Speer later admitted that the Reich had expected thousands per month, a figure that would have turned central London into ruins. Instead, the offensive stalled. Part of the reason was material scarcity, part of it was transport collapse. But a critical cause one the Germans understood only after the war was Operation Crossbow itself. The Allies had not stopped the V-weapon program, but they had throttled it, cutting off fuel, disrupting parts production, destroying trained crews, and forcing the launch network to operate in fragmented, improvised bursts rather than sustained waves. By late 1944, as Allied armies advanced toward the German frontier, V-weapon units were pushed back, losing firing arcs on London. The bombardment shifted to Antwerp, the last major port needed for Allied logistics. Even there, despite hundreds of rockets, the scale never approached the original German vision. Crossbow had ensured that the VO weapons remained a terror weapon, not a war-winning instrument. The campaign demonstrated a critical truth of modern conflict. Wars are not won only by destroying weapons, but by dismantling the systems that make them possible. Crossbow targeted scientists, fuel shipments, machining centers, launch crews, storage depots, and the fragile industrial chain holding the program together. The result was not total elimination but near total suppression. By the spring of 19, Allied intelligence had refined a cycle of counter-V-weapon operations that functioned almost mechanically: detect, confirm, classify, strike. But the Germans were learning. They shifted launch crews at irregular intervals, relocated fuel dumps, and relied on camouflage that blended into the French countryside. What had once been static sites became nomadic threats. A single team could assemble a V-1 launch ramp in a few nights, fire dozens of missiles, and vanish before reconnaissance aircraft returned. Crossbow's success now depended on speed. The ability to identify a launch signature before it matured into a salvo bound for London. Photo-RECCE. Pilots of the RAF's 2nd Tactical Air Force flew at extreme low altitudes to force German teams to reveal themselves. If a convoy transported liquid oxygen tanks, if engineers laid out a rail line in a strange orientation, or if a forest clearing appeared scorched, the photographs were rushed to analysts and Analysts did not guess. They measured shadows, angles, structural changes, soil displacement. Data flowed to Eichsbomber Command, which in turn tasked Marauders, Mitchells, and Mosquitoes to strike before the Germans launched. The loop tightened into a rhythm of surveillance and suppression. Yet the V-2, the world's first ballistic missile, remained the greater fear. It could not be intercepted. It could not be jammed. It arrived without warning. The only way to stop it was to destroy the missile, the fuel, or the engineers before launch. That required identifying flame trenches. Even so, intelligence officers warned that the threat was not gone. The Germans were still launching V-2s from mobile sites inside the Netherlands, impossible to pre-strike and unstoppable. In flight, Crossbow's mission was shifting again. It was no longer about preventing thousands of rockets from hitting London. It was about ensuring that the next wave, whatever its scale, would be smaller, shorter, and strategically meaningless. The battle moved into its final phase, where analysis mattered as much as explosives, and where the war's outcome would hinge on whether Allied destruction outpaced German innovation. By early 19, the full scale of the V-weapon system was finally exposed. What Allied intelligence had once treated as scattered clues, strange test stands, concrete ramps, fuel depots, sudden German secrecy was now visible as a vast network stretching from the Baltic to the Bay of Biscay. Crossbow had begun as a race to prevent London's destruction, but it ended as a methodical dismantling of an industrial empire built on forced labor, chemical fuels, precision machines, and underground engineering unmatched anywhere else in Nazi Europe. The Dora-Mittelbau complex revealed this most clearly. When American troops entered the tunnels, they found assembly lines carved into stone, rail spurs pushed deep into caverns, and long rows of unfinished V2S lying on wooden supports. Engineers studying them realized the scale of the undertaking: gyroscopes, turbopumps, alcohol liquid oxygen feed systems, and guidance vanes that required tolerances far beyond typical German production. The rockets were technically brilliant and strategically insufficient. Crossbow's bombing campaign had not eliminated them entirely, but it had strained the system to the point of collapse. Every destroyed ramp, forced relocation, every delayed shipment, slowed assembly, every raid on Peenemünde set German engineers back weeks. By the spring of 1945, the VO-weapon program existed only as debris scattered across retreating front lines. For London, the outcome was stark. Instead of thousands of missiles falling, Dahlia's German planners once promised Hitler, the capital endured terror, but not annihilation. The V-1 assault declined as launch sites were captured. The V-2 bombardment never achieved decisive volume. Intelligence, deception, and relentless air attack had disrupted the ambition at its root. The British Ministry of Home Security, reviewing the data after Germany's surrender, concluded that without Crossbow, the casualty count would have been several times higher. Even conservative estimates indicated that sustained launches could have overwhelmed civil defense measures, and crippled wartime industry across southeast England, yet the story did not end with Germany's defeat. Both the United States and the Soviet Union moved quickly to seize surviving V-2 components, documents, and personnel. Operation Paperclip transported German rocket specialists, including Werner von Braun, to American facilities for interrogation and eventual employment. The Soviets captured test stands and fuel systems from wartime sites in Poland and eastern Germany. The technology intended to destroy London instead became the foundation of early Cold War missile programs. Within a decade, derivatives of the V-2 would lift the first satellites into orbit and define a new era of global strategy. For the officers and analysts who had run Operation Crossbow, the legacy was done. Their success prevented catastrophic losses, yet they understood how close the Allies had come to facing a weapon that could not be intercepted, tracked, or deterred by any existing defense. The post-war evaluations emphasized the vulnerability. Nations could no longer treat long-range missiles as theoretical threats. Air defense, radar, signals monitoring, and rapid strike bombing doctrine all evolved directly from Crossbow's lessons. What began as a wartime emergency became the blueprint for confronting missile warfare for the next half-century. As Europe rebuilt, the ruins of launch bunkers and cratered test sites remained concrete markers of a campaign fought in secrecy and urgency. The civilians who had endured the attacks remembered the sound of falling V-1 South, the sudden silence before impact, the violence of the V-2 South that arrived without warning. Their survival was not guaranteed. It was earned through intelligence networks, photographic reconnaissance, and the willingness to strike targets buried deep inside occupied territory. Operation Crossbow had no single battlefield, no front line, no victory parade. Its triumph was measured in the destruction that never came, the thousands of rockets that never reached London. The cities never burned, the lives never lost. In a war defined by visible devastation, Crossbow's achievement was the prevention of devastation itself.